Today we are discussing about the basics of number systems. Basically, daily used numbers are 1, 2, 3, 4, etc. up to infinity. This set of numbers are called natural numbers. Next, the set of numbers starting from 0 and continuing as 1, 2, 3, etc. up to infinity is called whole numbers and it's denoted using the letter W. Next is a set of integers. Is set is denoted by Z and it is start from negative infinity and continuing as negative 3, negative 2, negative 1, 0, 1, 2, 3, etc. and continues up to infinity, positive infinity. Next is rational numbers. The set of rational numbers is denoted using the letter Q. Any number which can be written in the form of P divided by Q, with P and Q must be integers and Q not equal to 0, is called rational number. So any number which has a P by Q form is called rational number. In rational number, the collection is denoted by the letter Q. The reason is Q comes from the word quotient and rational comes from the word ratio. Irrational numbers are not rational. So all numbers which are not rational are called irrational. That means the property of irrational numbers is they cannot be written in the form P by Q where P and Q are integers with Q not equal to 0. So here we have discussed the number system, basic family of numbers or basic set of numbers. Next, we can conclude a few results from this classification. First one, all natural numbers are whole numbers. This is very clear because we know what is meant by natural number and what is meant by whole number. We know the natural numbers are the set of numbers starting from 1, 2, 3 and continues up to infinity. And whole numbers is the same set of numbers but it is starting from 0. So 0 is an extra element different from the set of natural numbers. Second, all whole numbers are integers. It's also very clear. Integers containing the negative value of natural numbers. So all whole numbers are included in the set of integers. So all whole numbers are integers, but all integers are not whole number because integers containing negative numbers, but whole numbers does not contain negative numbers. Third result, all integers are rational numbers. This is also very clear because all integers we can written in a P by Q form. So all integers are rational numbers. And all fractions are also rational number because a fraction is already in P by Q form or numerator by denominator form. So all fractions are also belongs to rational number and all integers are also rational numbers. But all rational numbers are not fraction because all whole numbers, integers, natural numbers, all the set of numbers belong to rational numbers. And next final result is the real numbers include all the rational numbers and all the irrational numbers. The system of numbers or the collection of numbers containing rational numbers and all the irrational numbers are called real numbers. Next, here we can see a chart representing the classification of real numbers. Here we can see real numbers are basically classified into two collections. One is rational numbers and other is irrational numbers. Rational numbers and irrational numbers together is called real numbers. And rational numbers is again classified as non-integer rational number and integers. Integers are again classified as negative numbers and whole numbers. So whole numbers are starting from 0 and ending up to infinity. All other numbers in the negative side is called negative numbers. So negative numbers and whole numbers together is called integers. Then again whole numbers can be classified. 0 is there and natural numbers is there. So in the set of whole numbers, all numbers except 0 are natural numbers. The same concept we can see with the help of a diagram. Here in this chart, we can see the real number system. The entire collection is called real numbers. The full collection is called real numbers. Real numbers containing rational numbers as well as irrational numbers. So in rational numbers, there is a subgroup which is integers. In the set of integers, again there is a subgroup that is called whole numbers. In the set of whole numbers, all the numbers except 0, that means a subgroup of whole numbers is called natural numbers. So natural numbers are included in whole numbers, and natural numbers and whole numbers together included in integers, and natural numbers, whole numbers, integers together included in rational numbers, and all these numbers together included in real numbers. So real number includes rational numbers and irrational numbers. Irrational number is a set of numbers which is different from this big set of numbers. Next, we can move to another discussion. Here, think about the real number line. Here is a simple result we can see while thinking about the real number line. Every real number is represented by a unique point on the number line. Also, every point on the number line represents a unique real number. Okay, whenever we are touching any individual point on a number line, that particular point represents a unique value of real number, and every unique value of a real number have a unique place in number line. This is explained here. In this picture you can see the unique value of a few set of numbers. Next, there is a question: which is the smallest positive real number? The question means we want to find, we want to think about the positive number, and must be smallest and positive. So smallest and positive means it will be more closer to 0. So the question can be rethink as which positive value is most closer to 0? Is it 0.1? We know 0.1 is obviously very close to 0, but here in the bottom you can see there are many values between 0 and 0.1. 0.01, 0.02, 0.03, etc. up to 0.09, all the values lies between 0 and 0.1. So, is it 0.1? No, because 0.1 is greater than 0.01, or 0.01 is less than 0.1, and 0.01 is more closer to 0. So, 0.1 is not the smallest positive real number. Then what will be the smallest positive real number? Is it 0.01? Never. Why? Using the same logic, you can see 0.001 is again smaller than 0.01, or 0.01 is greater than 0.01. So, thinking like this, we are continuously considering the numbers. There are lot of smallest numbers which is less than the previous one. For example, 0.01, 0.001 is greater than 0.0001. Again 0.00001 is again smaller. 0.000 100 times 0, then after 1 is again smaller. 0.000 1000 zeros after 1 is again smallest number. These all are very 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 close to 0, and again there are infinite number of numbers before 0. So what will be our conclusion? Thus the conclusion is that the most smallest or greatest positive or negative real number is the only one answer, not defined. Such a number is not defined. The smallest number is not defined. The greatest number is not defined. The smallest or greatest positive or negative real number is not defined. So, from this discussion, we can see this happen between any two real numbers. We have seen that 0.01, 0.0001, 0.0001, etc. up to infinite number of numbers. These all numbers lies between these very two close values, that is 0 and 0.1. All these values we have seen, there are infinite number of values are lies between these two closest point 0 and 0.1. So from here we can conclude that this will happen between any two real numbers. So we can arrive at the result, there are infinitely many real numbers between any two given real numbers. This will happen, and this is true for a very rational numbers also.